Pyranose structure of D-glucose. The experiments conducted on D-glucose has confirmed that D-glucose has 6-membered cyclic hemiester structure. 6-membered cyclic structure of D-glucose is called a pyranose structure. Pyranose structure of D-glucose resembles the structure of pyran, a cyclic compound containing 5 carbons and 1 oxygen present in the ring form. The exact structure of D-glucose is given by Haworth and it is called as Haworth structure. The Haworth structure of alpha and beta anomers are represented as follows. Let us learn how to draw Haworth projection formula for both alpha D-glucose and beta D-glucose, the isomers of D-glucose. Step 1. Firstly, a 6-membered cyclic ring with oxygen at upper right corner is placed. It is called as pyranose ring, which has 5 carbon atoms and 1 oxygen atom. It is numbered from 1 to 5. Step 2. 6 carbon in D-glucose is CH2OH, a primary alcohol group. CH2OH group is always placed above the plane of cyclic pyranose ring, that is upward position, and it is attached to 5th carbon. Step 3. All the hydroxyl groups present on the right hand side of Fischer projection are placed below the plane of cyclic ring, pointing downwards. For example, in Fischer projection of alpha D-glucose, hydroxyl groups are present attached to C1, C2 and C4 are towards right. Hence, they are placed below the plane of cyclic ring as shown. Whereas the hydroxyl groups present on the left side of Fischer projection are placed above the plane as shown. The respective hydrogens are placed above and below the plane of cyclic ring. Finally, Haworth projection of alpha beta D-glucose are drawn as shown. These two isomers are called anomers. Since these forms has pyranose structures, alpha and beta D-glucose isomers are named as alpha D and beta D glucopyranoses. Let us study about fructose. The molecular formula of fructose is C6H12O6. It is highly soluble in water. Fructose is the sweetest sugar. In nature, fructose is present in honey, and naturally occurring fructose is levorotatory. Structure of fructose. Fructose molecule consists of a keto group at C2 carbon center and has 2 primary alcohol groups CH2OH at C1 and C6. Further, the molecule has 3 chiral centers at C3, C4 and C5. Glucose and fructose on treating with 3 moles of phenylhydrazine form same osozone. This indicates that both C1 and C2 carbons of glucose and fructose involved in osozone formation. From the above reaction, one can conclude that 3 chiral carbon centers of fructose are at C3, C4 and C5.